This is lesson 6.5, the coordinate plane. In this video, you will learn to describe the location of points, plot points, and find the distance of points on the coordinate plane. The coordinate plane is formed by the intersection of a horizontal number line and a vertical number line. The number lines intersect at the origin and separate the coordinate plane into four regions called quadrants. It's going to be very important that you know how to label these quadrants. They start over here in the upper right hand corner with quadrant 1, and they go counterclockwise, quadrant 2, quadrant 3, quadrant 4. You will be tested later on how to label these. So quadrant 1, upper right, quadrant 2, upper left, quadrant 3, bottom left, quadrant 4, bottom right. The origin is right in the center at 0, 0. The x-axis goes up and down. The x-axis goes across and the y-axis goes up and down. An ordered pair is used to locate a point on a coordinate plane. The x-coordinate tells you to go across, the y-coordinate goes up and down. We did this in a previous chapter, only we didn't have negative numbers. That's the only difference. So now we're going to go into all these other coordinates, quadrants, with our negative numbers and plot points that way. Example 1. Which ordered pair corresponds to point T? Well, here's point T right here. And to get there, you start at the origin and you figure out how far you go across. In this case, you go across 3 spaces. And then you go down 3 spaces. So if you're going to go to the right, it's the positive direction. So that x-coordinate is going to be positive 3. And then if we go down, that's the negative direction on our number line. So that's going to be negative 3. So if we look at all of our choices over here, we need an x value that's positive. So it's going to be either C or D. And then we need a y value that's negative. Well, then it must be C. Example 2, plotting ordered pairs. A is negative 2, comma 3. So again, we always start at the origin. We start at the origin. We're not going to draw a line as we go over. We're just going to start there and place our finger there and move along the grid as we go. So negative 2 tells us where to go left or right. If it's negative, we're going to go to the left. If it's positive, we're going to go to the right. So negative 2 tells us to go 2 to the left from the origin. So we're going to start right here and pointing to the origin. I'm going to go 2 to the left. And then the 3, that's positive, we're going to go up. So we're going to go up 3. If it were negative, we'd go down, but it's positive, we're going to go up. So we're going to place a dot right there. Trying to get a spot. I don't have a stylus again, so I'm trying to use my finger. That's negative 2, comma 3. Alright, so part B, we have 0, comma negative 3.5. Remember that first one tells us whether to go left or right. The second one tells us whether to go up or down. So this tells us to go over 0. So we're not really going to go very far. Okay, we're not going to go left or right because it says to go over 0. And then it says go down 3.5. So I'm going to go down, right here would be 3. Then I got to go down another 0.5, which is halfway between the 3 and the 4. So this point is going to be right on the y-axis. So I'm going to place it as carefully as I can with my finger. Well, I'm trying without my stylus. You get the idea there. It's right on the y-axis. And then it says describe the location of each point. So the first one, when I describe this, I'm going to say which quadrant it's in. If you remember from that last slide, we start in the upper right. That's quadrant 1. And then it goes counterclockwise. Quadrant 2, and we use Roman numerals to number them. Quadrant 3 and quadrant 4. So A is in quadrant 2, and then B we can say it's on the y-axis. And if you wanted to, you could say it's between quadrant 3 and quadrant 4. That's how you describe the location on a coordinate plane. Example 3. An archaeologist divides an area using a coordinate plane in which each unit represents 1 meter. The corners of a secret chamber are shown in the graph. What are the dimensions of the secret chamber? Okay, so you can see all 4 corners right here, and they all have dimensions on them. In chapter 4, we did some very, very similar problems. In the book, in the example, they use absolute value to find this and finding the distance from each axis. But I think if you did this like we did in chapter 4, you would have a much easier time. So what we're going to do is we're just going to count the spaces in between each point, because we're just trying to find the distance between each one. So first, let's go from here to here. The space between there is 1, 2, 3, 4, 5, 6. And if it's 6 there, it's 6 here. The space between here and here is 4. And over here it's also 4. So we can see here that the dimensions of this secret chamber are 6 meters by 4 meters.